Hello guys, this is Dr. Maha Abdurrahman. I'll be facilitating a short tutorial today about chromatography, and let's start with the first question about the student investigated a food dye using chromatography paper. Now he placed the spot of the food coloring X on the start line. You can see it right there. So this is point X, and then he placed 4 other separate dyes A, B, C, and D on the start line. He placed the bottom of the paper in water and left it for several minutes. Write down 2 mistakes that the student made in setting up this experiment and explain what problems one of the mistakes could cause. Now, this question is very common, okay? And usually they ask about the same mistakes every time. So the first mistake, as you see here, is that the start line is drawn in ink. So that's the first mistake, is that start line is drawn in ink. Of course, this will interfere with the result. So because the ink will run with water and interfere with the results Now the second mistake, as you see here, is that the baseline with all the samples is below water. So I would write that the start line is below the water. This of course will dissolve. So why is it a mistake? Because it will dissolve the sample, which is the food coloring, and the dyes as well. Okay, so those are the 2 mistakes, and I mentioned that this is a very common question. And the second or part B of the question, that another student set up the apparatus correctly, and then these are the results over here. The result for dye D is not shown. Now calculate the RF value of dye A. Basically, the RF value is the distance, as we all know, that has been traveled by the dye. If I want to call this A, over the distance that traveled by the solvent, and I'm going to call this B. So basically, it's A over B. Basically, it is A over B, and if you measure the distance A, it would be around 2.8. We're going to divide it by distance B, which is the distance traveled by the solvent. It's going to be around 8.2. Now, the thing that they wanted to 2 significant figure, you should abide to the significant figure required, not more than 2 significant figure, and don't round less than 2 significant figures. It should be exactly 2 significant figures. So that's why I would write the answer 0.34. So I'm rounding it to the 2 significant figure. Now let's move to the other part of the question. Now dye D has an RF value of 0.8. So basically here they gave you the RF value. So here I was finding the RF value, but here the RF value is given, and they really want you to calculate the distance that dye D moved. So that's why it's not drawn. Okay, so basically the RF value is the distance, as we mentioned. It will be the distance traveled by dye D over the total distance traveled by the solvent, which we already got in the first question. So the total distance was 8.2. I'm going to call this A, and then the RF value is given 0.8. So to find A, you're just going to multiply 8.2 times 0.8, which will be 6.6 centimeter is the distance traveled by dye D. Okay, now explain how the different dyes in X are separated on the chromatography paper. As you see here, guys, This is the food coloring, and it shows that it has dye C. It has as well dye B, and it has one other dye that's not identified. Okay, so dye C and dye B over there. So what basically is the idea of chromatography that made this food coloring separate into more than one component? This is a 4 marks question, and basically how the different dyes in X are separated by paper chromatography. The idea really here is that the components or the different components in dye X has different solubility in water, so has different solubility in water, and I'm saying water because the solvent that was used here was water, so has different solubility in the solvent, which is the water here. Okay, and so basically they have different solubilities water, and as well they have different absorption power to the stationary phase. Okay, and this is really the idea of the chromatography. How soluble is it in the solvent, which is the mobile phase? Okay, I'm gonna add that here. So let me add that the solvent here is the mobile phase. Okay, and it has also different adsorption to the paper, or different attraction on the paper, which is the stationary phase. And this is really what decides when will the component in the dye be separated. Okay, so the component in dye X have different solubility in solvent, which is the mobile phase. Okay, and different adsorption or attraction, different attraction to the paper, which is the stationary phase. Stationary phase. Okay, as the solvent moves through the paper, the components would be separated at different distances depending on how soluble they are in the solvent and how good they are absorbed on the paper. So will be separated at different distances. Okay, according, I'm gonna add that as well. So according to the solubility and in the solvent, and as we mentioned before, and the attraction on the paper. So this is really the difference, or how the technique of chromatography works. This has 4 marks. So referring to the solubility in the solvent, you're gonna get 1 mark. Referring to the adsorption on the stationary phase, 1 mark. And referring to that other idea that the solvent moves and that every paper, or every component will be separated at different distance, this also you're gonna get 2 marks on that. So this how the marks are distributed on that question. Now here, this actually, guys, is another question. Okay, I picked part C out of it. Esters can be used as solvents on chromatography. The following shows a chromatogram of plant acids. Okay, as you see here, we have 2 samples. An ester was used as a solvent, and the chromatogram was sprayed with bromothymol blue. Suggest why is it necessary to spray the chromatogram? So usually when we spray a chromatogram, this is because the plant acids usually is colors, so that's why, or that is the reason why we usually spray the chromatogram. So I would write here the plant acids are colorless, okay, and we need to make them visible. So spray to make it visible, to make the spots colored or visible, colored or visible. So two information, that it's colorless one information, and to make it colored or visible is the second mark. Okay, explain what's meant by RF value of the sample. This was explained in the first class, so the first question. Now the RF value is the distance traveled by the solvent over the distance traveled by the solvent. So I'm going to write that here. It is the distance traveled by the sample over distance traveled by the solvent. Now, as RF value high, that means that the sample is more soluble. Makes sense, right? That's why it's traveling further, because it is more soluble in the solvent. Now, this is just an extra information I'm conveying to you. It's not required in the question. Okay, now let's continue the last part. Calculate the RF value of the two samples and use the data in the table to identify the plant acid. Now, sample 1, the RF value was, so I need really to measure the distance over there. It is 0.2. After we measure the distance traveled by the solvent, by the solute over the distance traveled by the solvent, we will find that the answer is 0.2, which is very close to the tartaric acid. So I would say this is tartaric acid. Then sample 2, after measuring the distance traveled by sample 2 over the distance traveled by the solvent, you will find it is 0.44, which gives me the malic acid, or very close to the RF value in the data book of the malic acid. So here I recognized the sample and I identified them as well using the RF value in the data book. I hope this short tutorial was useful. Now subscribe in my channel for more videos and more tutorials. Thank you so much, and see you next video.